Okay, I'm supposed to evaluate this integral. Again, this is a good way for them to give a problem where you can use your calculator if you like, but it just doesn't help. So to find the value of this integral, I've got to find this antiderivative first. That's kind of a mess. So I'm thinking u substitution, because I have two functions being multiplied here. Let's erase this. So I've got two functions being multiplied. I've got f prime of g multiplied by g prime of x. And if I say u equals this g, then the derivative of my pick, du over dx, that's going to equal g prime, which is the other of the two multiplying functions. So that looks really good. I need to remember to change my limits whenever I do a u substitution. So u is going to equal g of, the lower limit is, we'll do the upper limit, 3, g of 3. Come back up to the table. G of 3 is 1. And then I have u equals g of negative 2. G of negative 2 is negative 1. Right here, if I multiply the dx across, I end up with du is equal to g prime of x multiplied by dx. So now I can change the integral. This integral is going to equal the integral from negative 1 to 1 f prime of u, because u is equal to g of x, multiplied by g prime times dx is just du. The antiderivative of f prime, this is the fundamental theorem. This is f of u, and then bar negative 1 to 1. It should be f of 1, subtract f of negative 1, so looking up at the table, f of 1 is 7, f of negative 1 is 8. Check the scoring guide. And of course I made a mistake somewhere. Let's pause so I can... Yep, just get too casual. F of 1 is 2. I was finding f of 3. F of 1 is 2. So this is a 2 minus 8. That is the correct answer. You don't have to go any farther. If you do write down in your paper correctly negative 6, they'll also give you the point, but you could have stopped. Basically, if you get to here, they give you 2 points. You don't have to write this stuff out. I think it's smarter to write it out. But if you can get to here, they give you 2 points. If you finish the problem, they give you 1 more.